welcome back to my YouTube channel. Our topic for today is sets. So we are coming to solve more questions on sets. Question number 1 says U, that's the universal set, is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, and the curly bracket is close. Is the universal set. So that's the universal set U, which is 1 to 12 is the universal set. And X is equal to, S is said that S is even. So S is even numbers in the universal set. Okay, then Y is equal to, S is said that S is what? Prime. Yes, so X is prime in the universal set. So they are all subsets of U. List the element of I. X union Y. I, X intersection Y complement. So that's the problem. So first of all, we're supposed to write the universal set, right? Supposed to write the universal set. And you know the universal set ranges from 1 to 12. So you write them, right? So that's the universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the universal set. So after you have written the universal set, then S is equal to, S is said that S is what? Even. S is said that S is even. So you write that one as well. So even numbers in the universal set. And you know that even numbers, they are numbers that are divisible by 2 without remainder. So for them, if it is being divided by 2, there will be no what? Remainder. So from the universal set, what are the even numbers in the universal set? So we have 2, 4, 6, 8, 10, and 12. So these are the even numbers in the universal set, because when it's being divided by 2, there will be what? No remainder, right? So you write them. After that, Y is equal to, S is said that S is prime. So the prime numbers in the what? Universal set. You know that prime numbers are numbers which are divisible by 1 and the number itself, right? It means for the prime numbers 1, the number itself only can go inside that number. So when it comes to 2, for 2, 1 can go inside and 2 can go inside the number. That 2 being itself can also go into the number. When it comes to 3, for 3, 1 can go inside 3, then 3 itself can also go inside. So that is what prime numbers. They are numbers which is divisible by what? 1 and the number itself only, right? So from the universal set, we have 2, 3, 5, 7, and 11 as the prime numbers in the universal sets above. Someone might ask that why is that 1 is not part? 1 is not a prime number, it is what? A composite number. So you write those prime numbers, ignoring 1, because 1 is not a prime number, it is a composite number. So I see that the first question says find X union Y. X union Y. So union means you are adding, right? So you are adding the elements in X together with the elements in Y. So you have 2, you can see 2 there. So you have 2, you have 3, you have 4, you have 5, you have 6, you have 7, you have 8, you have 10, you have 11, you have 12. Yes. So you are just summing up the elements in both X and Y. When there are 2, maybe you have 2 in X, you have 2 in Y, you write on one of them. But you don't have 3 in X, but you have 3 in Y, you write it. You don't have 3 in X, but you have 3 in Y, you write that one as well. So you are summing up, right? Okay. Okay, so II says find x intersection y complement. So for you to find x intersection y complement, you're supposed to find y complement, right? What are y complements? So they are the numbers in the universal set that are not in y. Y complements are the numbers in the universal set that are not in the y. So what are those numbers? So we don't have 1. Where is it? We don't have 1 in the y. We don't have 4 for y. We don't have 6 for y. We don't have 8. We don't have 9. We don't have 10. We don't have 12, right, for y. So these elements are what? Y complement. So it lists them. Now you have been able to write the y complement, right? So x, the values of the element of x is being known as well. So now x intersection y complement. Intersection means numbers that can be found in x at the same time can be found in y complement are the what? Intersection. So what are these numbers? So if you check it for the x, we have 4. For x we have 4, and 4 2 is also in the what? In the y complement, right? Yes. Then for the x we have 8, and 8 is also what? In the y complement. For the x we have 12, and 12 is also what? In the y complement. So these are the what? Are the intersection of x and y complement. That's 4, 8, and what? 12. So that's the value, or that's the answer for x intersection y complement, 4, 8, and 12, because these values can be found in both x and y complements, right? Can be found in both x. These are the elements in x, and these are the elements in the y complement. So these values can be found in both x and y complement. So the solution for question 1. If you have any question, you can drop it on the comment section below so that I can attend to you. So now we are moving to question 2. Okay, so example 2. For the question 2, we say m is saying that x is a factor of 20. So x is a factor of what? 20. Then n equal to s is say that s is a multiple of what? Of 4. And t is equal to s is say that s is greater or less than 11. Greater or equal to, sorry, so s is say that for the t, s is say that s is greater or equal to 11 but less than 18 as subsets of the universal set. And then the universal set is used equal to all integers from 1 to 18. Yes. So it says list the elements of I, m intersection n complement, II, n intersection t complement. Okay, so now you have to list the members of the various set first. Like, okay, then you start with the union set. And the union set is saying that all integers from 1 to 18. So from 1 to 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 18. So all integers from 1 to 18. Okay, so that's the union set. U is equal to all the possible integers from 1 to 18. So I've written there. Then n is said that m rather is a factor of 20. What are factor of 20s? They are the numbers that can go inside what? 20, right? Factors of 20, they are the numbers that can go inside the 20. So 1 can go inside the 20, 2 can go inside the 20, 4 can go inside the 20, 5 can go inside the 20. Without remember, then 10 can also do the job, and 20 itself as well can also go into 20. But it should all fall within the universal set. So you cannot write 20 So 20 can go into 21, but you cannot write it because all the values you are going to write should fall in within the universal set, which we need from 1 to 18. Okay, so as a matter of that, you end at what? 10. Yes. Okay, so these are the numbers that can go, the factors of 20: 1, 2, 4, 5, and 10. Right. Then n I say that it's a multiple of 4. So what are the multiples of 4 in the universal set? So 4, 8, 12, and 16, right? So multiples of 4, they should fall within the universal set. Remember the universal set ends at 18. So the multiple of 4 will start from 4, 8, 12, and it will end at what? 16, right? Okay, so these are the multiples of 4. It should fall within the universal set. So now, since you'll be needing the n complement to solve for the I, let us list the elements in the n complement. That's the n complement, right? Let us list it. Okay, sorry, you have not done that of the t. We have not done that of the t. So let's list it before we come and list the members of the n complement, right? So for the t is saying that s is greater or equal to 11 but less than 18. So s is greater or equal to 11. It means 11 is what? Inclusive, but it's less than what? 18. So 11, 12, 13, 14, 15, 16, 17. These are the what? Are the elements for t. S is said that s is greater or equal to 11. Yes. So all those numbers must be equal to or greater than 11 but less than 18. So greater or equal to means 11 is what? Inclusive. So from 11 to what? 17, because it's less than 18, right? So 11, 12, 13, 14, 15, 16, 17 are the what element for t. So you write them as well. Now let's list the number. Let us list the number of the n complement. So n complement, they are the numbers in the universal set which is not in the what? N. It's not in the n. I hope I'm getting it. So the numbers that are here, that are in the universal set, that range from 1 to 18, in which the n doesn't have. I hope I'm getting it. Yes. So that's n complement. N complements are numbers in the universal set, but not in the n sets. So you can say you don't have 1 in the n set, you don't have 2, you don't have 3, you don't have 5, you don't have 6, you don't have 7, you don't have 9, you don't have 10, you don't have 11 for the n set. So they are the what? N complement. So you write them as such as well. Okay, so these are the values. So now we have to find for t complements because we'll be needing it to solve for the I. So t complement, they are also the numbers that are not in the t set, but it's also in the what? In the universal set, right? So now let us read it because this is the t set. 11, 12, 13, 14, 15, 16, 17. So what are the numbers in the universal set but it's not in the t? They are the t complements. You can see that you have 1 in the universal set but it's not in the t. 2, 3, 4, 5, 6, 7, 8, 9, 10, and what? 18. They are in the universal set but it is not in a t set. I hope I'm getting it. Yes. Okay, so they are the t complement. Now we have come to the main question. I. It says m intersection n complement. M intersection n complement. So for the m intersection n complement, they are the values that can be found in both m set and the n complement set. So where is the m set? So there's the m. You have 1, 2, 4, 5, 10, and the n complement too. N complement, you have 1, 2, 3, 5, 6, 7, 9, 10, 11. So what are the numbers that can be found in both sets? So we have 2, right? Yes, 2 is here, 2 is here as well. Then we have 5 is here, 5 is here as well. Then we have 10 is here, 10 is here. So these three values, or these three elements, can be found in both m and n complement. So you write them. So let's come to I plus n intersection t complement. So they are the numbers that can be found in the n set and the t complement set as well. So where is the n set? The n set have 4, 8, and 12. And the t complement set also have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 18. So which numbers can be found in both sets? 4. Yes, 4 is here, 4 is here. 8 is here, 8 is here. Yes, 12. You can find 12. So 4 and 8 are the numbers in which they are in both sets. Okay. Yes, so that is the solution for this problem. So we continue tomorrow with example 3 and 4. So we end the lesson. Have a good day. Bye-bye.